Well, then I'll introduce myself. So, Scott Gillespie. I work out of Tabor, Alberta, and I've been working on regenerative stuff for quite a long time. I've been mostly focusing on it for the last 5 years, but realistically, I actually did my master's degree in this almost 20 years ago on trying to bring regenerative, right? It wouldn't have been called that at the time, but it was trying to bring some of the organic practices into conventional to try to reduce some of the pesticides. So that's what I did, and I've always been interested in it. So today, what I'm going to be talking about is the cover crops and nitrogen cycling. So there's so many other things that they cover, but I think specific to what this funding or this field day is mostly about the cover crops and how nitrogen, the nitrogen cycle can be affected by it. So what I wanted to do, I got this forage measuring stick from a friend of mine, Karen Lindquist, and it has some approximate numbers onto it for estimating biomass. So before we even start on trying to figure out the differences between, or what we can expect from cover crops and nitrogen, we came to this is just a filler area. So we're gonna actually go out and we can measure it and try to figure out how much biomass is out here. Unless anybody has a good idea how much biomass you think is out here already.
Half a ton an acre right now.
Okay, well, we'll see.
Dry matter.
So I guess everybody, we can trample these, I think, right?
Oh yeah.
Come on out. And we've actually got a good test here because this is under the pivot, and then that stuff is missed by the pivot. So maybe I'll leave that there, and I guess come on out. We'll start doing some measuring. Well, let's start right here. How much ground cover do you think is here?
50%.
30. Anybody else?
With or without the kosher?
Well, it all counts.
Yeah, it all counts.
Well, I mean, the stick here, let's see here. Well, at 90%, they have 90%, they have 75%. So well, I don't think we have a lot here. That's not very thick, so that's showing 12 inches. But how much cover do you think is realistically in this here? I think it might even be, like in this here, it might be 25%.
Yeah, less than 30. Yeah.
Less than 30, or even less than that. So
not much.
It's on
Not
the corners
much.
now. Better if you go over there.
More culture.
now we don't have on here.
It works.
If we go with
Yeah.
the grasses, it's saying about 400 pounds per inch, but I don't think it's that much on a 90% stand. So if we divide that by 4, that would be 100. I'm doing it right, 100 pounds per inch. So 12 inches, I don't think that's that much. Because it's not much, because you can see it's a fairly, even within it, it's fairly thin. Let's see if we can find a thicker spot. It looked a lot. Want to go this way a little bit? There's a little better growth.
Yeah.
I think there's more kosher too.
Yeah.
But even here, there's not a lot. So even if we went on this here, let's see here. If we went with that 400, so even a 12 inches, if we say there's 100 pounds, I don't think it's 12. It would say that this is 1,200 pounds of dry matter per acres. And what did you say?
Half a ton.
There we go. Pretty close. So actually, there's actually more here than I thought there would be for what it looks like. But So let's talk about that. I'm gonna see where I wanted to go in the notes here. So when this crop is growing here, so we've got, if we call this a cover crop of being the cereals, how much nitrogen do you think is in this crop at this point? Anybody know?
80%. It's just about a flag.
So it's taken up about 80% of its nitrogen. Yeah, okay, yeah, that's another way of interpreting the question. So yeah, it's taken up about 80% of its nitrogen already. And then the actual plant, do you know how much what percentage a plant is going to have of nitrogen?
Okay, what's the yield goal here?
No, but I mean how much, like if you were just to try to calculate how much nitrogen you got sitting in that plant right now, in pounds per acre.
120 tops. What is this?
That'd be
30 bushels an acre times.
I think it's even, so, well, how do you calculate? How would you calculate it then?
Okay, 30 bushels an acre times 2.4. If it's a hard red spring or a durum, so that makes 75. I was way too high. If this is 100 bushels of irrigation times 2.4, that's 240 bushels, 240 pounds of N.
But right at this stage though.
This stage, 65.
65 in it. So another way to calculate it is just the percentage of nitrogen. There's different numbers on that. It could be 2 to 3% or some of the ranges that I've come up with. Okay, you're agreeing. So that's where, that's why I've been trying to learn how to calculate these biomasses or look at the biomasses. So if we do go on that, even if we say the 1,000 pounds per acre times 3%, that's 30 pounds is tied up in that plant right now. Does that make sense?
Some other numbers say 5.9. Where did I get that from?
Where did you get the 5.9?
I don't know, the nitrogen to protein conversion.
Okay. I was trying to get some general ideas on it, looking up, but it really varies on what you can get. But even then, so that would be where if you actually did a lab test, you'd know.
Yep.
But from my perspective, not many people are going to cut out here and actually calculate out how much nitrogen. So we got to kind of get a rough idea as to what's in there. Now, what if this were a legume plant that we had out here? What would be the difference in the nitrogen in it? Any speculation?
I would say it'd be less because there's less biomass.
I think it can be a little bit less in terms of what it is, what's in there. Yeah. And what about where the nitrogen came from? I'll rephrase the question. So this year, where did the nitrogen come from for this? If this were your cover crop that you're trying to grow?
The soil?
Yeah, all from the soil. So if we're looking at a legume, which would be a more traditional cover crop, if you're looking at trying to replace your nitrogen or trying to get more efficient on your nitrogen, where does the nitrogen in the legume come from?
Soil and fixation.
Okay, you got it.
Yeah.
That's actually one of the things that I've learned as I did a bunch of reading on this, is that you have to be careful when we're putting legumes in that we're not assuming that all the nitrogen we're getting from them is new nitrogen in the system. So the very first thing that a legume does is it's going to take up whatever it can from the soil, and then it's only going to start making nitrogen as soon as it gets lower or decides that it's worth putting putting the energy into those nodules.
Scott, even if there's not much nitrogen there, there's still some time lag, right? Like, it still takes like a month or something to get some production.
To get some production, yeah, and actually that's another good point. So when we're talking, because the focus, or what I'm focusing on, is about the nitrogen, or how much we can maybe try to grow, or how much we can try to get out of the system. So if we're looking at a cover crop in the fall, or even like right after an early harvest, that's kind of what I want to do, is we want to try to calculate out how much growth do we actually need to make it worth it. So if we use kind of those numbers, what kind of growth when you guys think about it, how much growth out of a legume do we need to make it worth our while to plant a legume cover crop?
I always understood that you had to get it to the flowering stage before it was really fixing nitrogen.
Yeah, that's kind
Yeah.
of a rule of thumb I've been
You?
using.
Yeah, so trying to getting it to the flowering stage, but also the biomass. So we were, so we're calculating, I think if you had a stand like this, or if you definitely want a thicker stand than this here. If we really want to get some nitrogen out of it, we need probably a full canopy, at least as full as this. So if we figured that this was a full canopy at 12 inches, and if we had 400 pounds per inch, we're getting closer to that. So that would be 4,000 pounds, if I'm doing my math right. Does that make sense? The 4,000. If we have 4 times as much, we'd have 4,000 pounds instead of 1,000 pounds. So if we take that same number, 4,000 pounds times 3%, now we're starting to make some nitrogen for our system.
Scott, does it matter if you grow your legume in a polyculture with a legume and a non-legume? In some of our intercropping stuff, we found that when you put in peas and canola, for example, the canola is a nitrogen pig, and if the peas are going to live, they have to fix their own. And we could tell that in our study. So maybe that's just when you grow it to maturity as opposed to a cover crop.
Yeah. So that so you would probably know more about the research on this side of thing, but with when you're trying to put like a polyculture or even just a 2 species mix, putting a legume plus a non-legume, I've seen lots of debate on that, or lots of different theories on that side of it as to whether you're getting enough nitrogen out of it, or whether they're sharing on it. Did your study look at finding whether the nitrogen moved into the non-legume or not, or was it just as?
Can I add to that question? Okay, I have a lot of producers ask me about alfalfa grass mix. Yeah, the grass steals from the alfalfa. I kind of find, okay, Lee kind of answered that as well.
Yeah, what we found in our work and in looking, and I don't have a lot of experience with cover crops when they're at an elementary stage, but the whole concept of having a legume, most of our legumes that we look at, and especially the forage legumes like clover and that sort of thing, they fix their own nitrogen, and most of what we sample is in a polyculture with grasses and that kind of thing. How much the grasses of legumin you get in that year, I'm not so sure, but the grasses, unless you're in a really high-end situation, they deplete the plant available end, and I think the legumes find it easier to fix their own. That's my experience, and we can see that because the atmosphere is isotopically distinct from the soil, so the nitrogen is different. So I can even go into one of Scott's studies and measure the nitrogen enrichment, and I could answer this question. I've never done it in cover cropping settings, but
From what I've seen on it, there's under a perennial system, when you have the alfalfa and grasses there, it seems like what happens is the alfalfa, when it dies down or when it roots prune or stuff like that, it seems like the grass can pick it up faster than it can right when things get growing again or in the spring, and that's where the long-term transfer of the nitrogen is. In a very short-seeded season cover crop, where the simplest would be the pea oat mixture, I don't think there's much transfer between the two of them. There are studies that are showing a little bit, where they can find some stuff moving, but I think that it's very limited. So the very first thing, and maybe this is where having a polyculture would help, is that if you had the oats in there that could take up that nitrogen faster than for the peas, and then you get the peas making you more. So, yeah.
You know, a lot of the interest in cover crops are in warmer, milder winter, higher rainfall areas. And
Yeah.
a lot of the benefit is not so much, it's preventing leaching and denitrification losses. Or lowering them, not preventing
You're
them.
taking my next point.
Yeah. No, but you know, because we got to look at, you know, what are the pathways of losses and gains, and you know, some cover crops that work good in Alabama do not work good here, and so that's just my comment. They're doing it for different reasons.
Yeah, and so that that was my next point, was to start talking about this side of it. So when we're looking at nitrogen here, what are ways we lose nitrogen here in southern Alberta? We'll start out just with a dryland system. How can we lose nitrogen in a dryland system?
Volatilization.
Like, so if it's spread on the surface and then not actually worked in. Is that, like, that's what you're talking about, or
Yeah,
even
but
just
even when if you band too shallow and you get like a hot windy day, you'll lose a bunch of that.
you'll lose some of it? Yeah. So that's one way of losing it.
So that's ammonia that you're volatilizing. That's the form.
Which isn't the very bad.
Well,
greenhouse
there's 3 or 4 different gaseous forms of nitrogen that we lose, but that's a very important one for sure.
gas. So you can lose nitrogen that way. Was there another one?
Too much rainfall leaching down into the soil, which hasn't happened for a number of years.
We wish sometimes.
Theoretically can happen. We'd like it to happen sometime.
So then can everybody think of the other? We're having to go up, we're having to go down.
Denitrification. Is that what you're looking for?
So denitrification, if I've got it right, is where it's too wet, right? They're very wet conditions, and it goes off as that nitrous oxide.
Yeah, denitrification, we lose it a number of gases. The main one is actually dinitrogen,
Okay.
N2, and that's a stable gas, 80% of the atmosphere, and it's very hard to measure. It's very important, and we don't talk about that enough.
So that's one one way. The other way is the other way that I was going for is surface losses. If somebody were to spread nitrogen in the fall, or spreading manure in the fall, and then you have the snow melt when it goes off the frozen ground, that's another way of losing nitrogen. Now on the comment on the going deep down, I remember in 2010. Does everybody remember 2010?
The flood year?
Yeah. Well, it was just like, I think there was dryland yields better than irrigated yields that year, because
I was going to mention that too. Like, we don't often have leaching, but we do have catastrophic events from time to time
that was
where
very
it likes to
interesting.
rain 6 inches in a day.
Well, and what I remember of it too was that we would have like a week of rain, and then it might dry up, and then I think it dried, or it kind of didn't rain for a while, then it rained another week. It just wouldn't stop raining. But what I remember was I was on a tour, because that was a year they were trying, they'd started some split nitrogen trials with Alberta Ag.
Yeah.
And I remember it wasn't part of the study, but it was more just it was just something they observed because they were doing it already. They were doing the soil test as a part of the protocol of doing this split nitrogen, and they actually found even in those rains, only their early applied nitrogen was down in the 2nd foot. So even with all that, even in just one of the wettest years we can have,
Wasn't enough to move it.
it's still a lot of the nitrogen was there. And then of course all of our crops, cereals or canola, they're going to catch that eventually. So here, to your point, that's the thing, is that we don't have those huge losses like what happened in a lot of areas, like in the U.S. or in the eastern U.S. and where they have winters or thawed ground or rains, and goes down through the soil and out the tile grain. So realistically, what I was talking about that on is, what I'm trying to get to is that where a cover crop is actually going to pay you for your nitrogen, for what you put into it. So given all that, how much of a cover crop do you think we have to grow to make the nitrogen that we grab from the air worthwhile?
Question? How much does your cover crop cost?
Yeah, that's actually that's part of it. Yep.
How much does fertilizer
So how
cost?
much? Say we do get 60 pounds. Say we figure we get 60 pounds fixed out of a legume in the fall.
Okay, it cost me
what's
$100
nitrogen
to
worth now?
establish and $30 out. I'm backward for $70. Yes, I'm a frugal Dutchman.
So. But if you start out with if you gain 60 pounds of nitrogen, how much does that cost you in fertilizer? Or how much?
$30.
$30 on today's prices. Where it was a few years ago, then it would have been probably closer to that $60. But then that's where we have to look at how much we're putting into them for the cost and how much we're putting into them. So yeah.
Are there other things you're seeing other than just nitrogen? Because it's not the only aspect
Of the cover crops.
of legumes and stuff like that in rotation. Like there's things, when they do all these studies with, wheat after peas, they always attribute like a factor where it's like a non-nitrogen benefit, they call it, I think.
Yeah.
So how do you account for that also so if you're going just on straight dollar amount,
Yeah.
how do you calculate what you're gaining that's not necessarily nitrogen?
See, and that's one of the most challenging parts of it is trying to get all the benefits put together into some type of number or try to figure it out. So, I mean, the focus of today or this talk today is basically about how the nitrogen and the cover crops work. So going back to like what Ken said earlier, in other areas, if your cover crop can grow into November, and then sometimes even start growing again in March, and pick up. Some of them can pick up a lot of nitrogen, 50 pounds, maybe 100 pounds of nitrogen that otherwise would have been lost in the system. You're paying for everything you're doing right there, just with the nutrients, and then you can add on some of that other stuff. So if we talk dry land here, I just don't see how they can make anything pay, especially right now. The only way I can see cover crops paying long term on dry land is as a fallow replacement, which I don't know if anybody's ever heard of some of that work or some of that idea. Is it?
The secret sauce of making cover crops pay is having livestock in the system, so that we do a double take on the cover. We get sheep or cattle through the winter, and we keep our nitrogen, our nutrients. Sorry.
You have potential of keeping them, but if that manure, if the manure runs off,
Then we have a bumper crop because we have moisture.
okay. So, well, see, this is where it's not an easy. So I'm gonna try to answer the question there. So, to me, on dry land, it's very tough to make the case for it to work unless you can go back to a fallow system or start using the fallow system where you grow a crop one year and then the next year you grow a cover crop that uses a lot less water than your main crop would. So you're saving water and then you're building the soil at the same time so that you can capture more water in.
I was involved in fallow replacement using green manure
Yep.
legumes back in the early 80s, and what we found, because if you're fallowing for moisture conservation, it doesn't work too good, because even though you use a third of the moisture during the fallow, you're growing the legume cover crop. You grow a poor growing cover crop with not much moisture, and then that lower moisture being carried into the next year lowers the yield of the subsequent crop. And so Well, and then when there was enough moisture to grow a really good cover crop, you might as well have planted a crop and got some money from growing canola or wheat or whatever. And so it is a challenge. And so we found in central Alberta it was a little more practical to grow a nice cover crop, add lots of nitrogen. We got a good response from the following crop. But then the question was, well, maybe we should have just grown a crop that year instead of the cover crop. So there's always that.
So that's the aspect of it on dry land. On irrigation, I think we have a better there's more that we can do with it. So say for example, if we are going to try to start putting cover crops into irrigation, now most years we have all the water we need. This year it actually is not the case, at least in some of the districts, especially in the Lethbridge Northern one. If we have that and we can get some nitrogen, say if we can grow enough nitrogen to pay for what we put the crop in, the cover crop in, where the benefit is going to come is that we're going to be keeping the soil, keeping we're getting the system cycling so that we've built up that nutrient level, and then as we can start trying to figure out how to learn how that, when it releases, then we can count on that for the crop, and then the next cycle comes. So say the crop either needs more or less, it has all the nutrients it needs, but then you have another cover crop ready to pick up what's left over, and we don't lose anything from the system. Now, in terms of all the other things that are talked about, like with carbon sequestration and soil health, those are a lot tougher things to measure. We could get into that too, but I can tell you that the carbon sequestration is not what people think it is. So it's not as magical as just putting it in and we start sequestering carbon. So now I wanted to know on the time, like how much time do I have, or where are we at?
Jamie told me she was tracking time. I didn't have to pay attention.
Okay. I'm good. Keep going. Okay.
I'll tell you.
I tried to say that because I knew she was looking away.
You want to know how much you have left?
Oh, we got lots of time. Lots of time for discussions and conversations, and then we can move on. Lots of time for discussions.
Well, that's
That's what you wanted to cover?
pardon?
That's what you wanted to cover? No pun?
Uh-huh.
Yeah.
Scott, I was kind of wondering about your experience with the different species and mixtures of cover crop. You know, we've got studies at Ag Canada, the research center, and you know, people ask us, well, are these still relevant because we shouldn't be summer fallowing anymore? But essentially, they are fallow replacements, but it's not really a cover crop. It's sort of a cover crop. Most of the current cover crop research, it looks like crops growing, it's not a forage crop, it's solely for the benefit of productivity in the system and to protect the soil in a continuously cropped system. Is that a right definition? And I wonder if you could comment on some of the species. We used to use sweet clover a lot, which of course is a biennial. It's a very different kind of a beast, and it's now regarded as an invasive species.
It fixed a lot of nitrogen though.
Yeah, so yeah, I guess you were first of all was about the cover, what a cover crop actually is.
Yeah.
Okay. To me, yes, a cover crop is something that is just for the soil and is not harvested. It was mentioned about grazing. I think that's that gray area. So definitely, if you grow, I've seen people selling what they call cover crops, and then they're telling people to silage them off. Well, that's not a cover crop. That's an annual forage.
Yeah.
You know, because you're exporting stuff off the land. There's no way around that. So now, if you're in a system where you're baling it and then you're gonna feed the cattle or feed out on that land eventually or that winter, well, I guess if everything's staying within your system, then maybe it is, but the grazing part is where that's where you see a lot of the celebrity farmers that I call them talk about the grazing side of things, and where they see the greatest benefit on it. But so it does cycle things faster because of course you put all the material through a cow and then it comes out the back end and most of it's still there actually. So the key is that it has to stay in place. So we were talking about that is whenever you graze it, if those cow patties or if that stuff actually just, if you get a rain or snow or something and runs them off, then that's no good either. So and actually something that I only just learned, did anybody hear of the new book out from Ag Canada here, Lethbridge, Dr. Kevin Float?
Mm-hmm.
Did anybody know the name of it?
There's something about dung beetles, I thought.
Yeah, cow patty critters.
Mm.
In his book, he says that up to 80% of the nitrogen in a cow patty just gases off or is lost.
Right on.
Which I was surprised at. So it's not a perfect system either. So
Scott, on that grazing bit, like, so I have growers that are, you know, they'll have corn or whatever, and then they'll put their cattle out for the winter, and then we'll try to seed into it. But when we go to seed into it, we got to rip the shit out of it to, sorry, we got to rip the crap out of it to get any seed in the ground. So we're really just going backwards in time when we do that, or do you have a suggestion as to make it more seed, like to make it a good seed bed for any crop? Because I've got canola coming up in some fields that the growers, we're all looking at it like, should we have ripped it up more? Should we have packed it? I don't know what the answer to that is.
So the grazing, like
they had corn in the field.
Yeah.
And then they grazed it over the winter.
Oh, like leaving the whole stalk and everything.
Yeah.
And
So I guess it's not grazing, but the cattle were out on the
land
during the winter. So it's,
but they leave it to grow to maturity, and then they send them out on it.
Yeah.
Yeah. That's a problem with if you the tillage isn't as bad as I think it's made out to be, but that is one of the problems, is that when these grazing systems you can so your question was more about
if there's a proper technique to making it more, we're basically trying to make sure that we're getting full use of that ground, right?
Yeah.
And with cattle guys, we got to utilize what we have, right?
Yeah.
If we
Compaction and all that.
the compaction is my biggest problem, is that those hooves, those cattle just destroy that land, and anywhere there's any feed or anything concentrated, those areas are basically, we can't seed into it. So do we rip it up a little bit deeper? Do we, is there a better answer to that soil? And are we just destroying it when we put those cows on it, or are we actually, because to me, if we can't grow on it, we've maybe hurt that soil, but I don't know.
I think do you have an answer to this? Or?
No, I'm just going to compound your problem since you're the presenter. This young lady here is the solution to what the challenge is. Combine the corn, leave the stover, graze it, okay? Feed the cattle on the land. Rah, 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 we're doing the environmentally right thing. Feeding cattle is $3 a day. We got them out on the stover, fantastic. But now all of a sudden we're impacting the rotation in a very negative manner, even though we're doing the right thing. So how can we do the right thing doing the wrong thing?
With putting the cattle out, like trying to get cattle out on the land?
Yep. That's where we want to be.
If I...
Only put them there when the ground's frozen or dry.
Okay. And in an annual production, like trying to utilize your annual
So you'll
fields.
wait longer is what you're saying. Maybe that'll help.
But some years that's really difficult.
Yeah.
You never know what's going to come.
That's right, yeah.
Yeah, I saw some heroic presentations where they were putting steel fence posts between every 3 rows or something, and controlled grazing through the winter where the ground is frozen, and they got way better use of the corn, and it was an amazing corn crop for how far, I think it was Lanigan, Saskatchewan or something, Bert Lardner stuff. But it looked like a heroic operation to me, where you're moving the fence line and and you get much better utilization of the crop. But it looked laborious to me.
And
And cold.
And so that works until you get a big snowstorm, and then or anything like that. Yeah, so a lot of these things. The only thing I can think of off the top of my head in terms of trying to make this work better is you keep the cows on the perennial system, and then you just try to do the annual. You concentrate on annual crops when you in your annual phase, and then you try to bring in perennial phases. The problem with perennial phases is that is the fencing. Like if you're going to have land, or to at least have the permanent fencing set up, is it? You have all
Oh,
these
they got those fancy collars now there.
I was thinking of,
Like your dog.
well,
No, they
that's-
work. Yeah, they use sound actually. It's interesting.
It's
Yeah.
you know what I think that's the thing is there are these things like
They're super
does
cheap,
anybody know
yeah.
like they're basically like an invisible fence for cattle.
Yeah.
But even on those, you still want to have a permanent, or you want to have a solid perimeter fence around wherever you are, because some of them don't obey the fence. So.
Especially if you're on the trans.
A lot of them use electric fences.
Well, but again, I think when we're looking realistically at what most people are going to do, there's a certain number of people that will be willing to put up with cattle on their land, but most people are not. So, yeah.
I guess to further on some of that, like I've got a guy that swath grazes
Okay.
like quite a bit with barley, and they direct seed everything, and they haven't had issues with that. So like I don't, and
Is that on-
maybe they're able to wait longer. Like I think they don't kick them out till probably December or January, so they're able to wait quite a bit longer. So I guess it depends on what.
Is that irrigated or dry land?
That's all dry land,
Dry land. Okay.
but that's in a little bit of a like south of here and a little bit of higher moisture area. So
Yeah.
that makes a difference too. But they've been doing it for like 15 or 20 years, and they've had good luck with it.
And
So
do they fence it out to keep them in certain areas at a time?
Yeah,
or-
so it's all fenced into I think there's 10 fields or something like that. But they keep their whole cow-calf pair operation over the winter on that land, and they're able to seed through it every year.
So
directly.
then they try to have a main crop like a wheat or canola or something.
Yeah,
and then try to get some feed growing.
It's
after.
just it's all monoculture, and they swath it in probably in a month or something. I'd let you know.
So, but they're not growing any annual crops like.
It's all annual.
No, I guess okay for
It's the
harvesting for
principal
seed.
crop. It's the first crop.
Their only crop is the swath that they're
Yeah, they're
feeding
not in a
animals.
rotation for cash cropping.
Yeah.
So that makes a difference too.
That makes a huge difference. 'Cause, I was going to bring it up at one point. We got going on other stuff.
Well, and their primary operation is cattle, so that makes a difference. So if
Yeah.
your primary operation is annual and you're trying to pull cattle in, that makes a difference.
That makes a big
But
difference. And
I'm just saying, like they've found a way to make it work.
Yeah.
On that system, on dry land with a no-till, and they've had good luck with it. So like it is possible.
It is possible,
You just
yeah.
have to want to do it.
Because
It's part of
you're
it.
probably talking irrigated land, right? Yeah. So
I'm
that's it.
trying to make like a lot of money.
Well, see, and I mean it's a good point on that. Is that like every situation you can adjust yours to what you're doing? Because like when you're dealing with irrigated corn, it's just massive amounts more stuff to deal with.
For sure.
Than that
Yeah.
there, and if they can swath it, and I don't know if they try to do it, but they might be able to swath it. They swath in different areas every year, right? Or if they,
I'm not
or
sure.
if they even worry about that.
I've only been working them for a little bit, so I'm not sure how they do it. But it's all, they'll swath on a 30 degree, and then they'll seed across it instead of like it's not always in the same
Okay, yeah.
weight
yeah.
to just try to be able to get through that.
I think we have 5 minutes or 4 minutes left.
Okay, I think it's the same as with zero till. The early adapters are going to bleed and learn how to make this work, because we need to learn how to make it work.
Yeah.
And
So that's where, like the no-till is a good perspective on it, because it's also the no-till. The first quite a few years, you need more fertilizer because now you've got a lot of stuff sitting on your surface. You've kind of got to get the system working, and I think with these cover crops or even like integrating grazing into it, it's going to take that time to kind of get that. Like that system that you're talking about, they've got a nice cycle going because they're grazing on it over the winter, and then they're planting something into it right in the spring, right? And then and especially with our climate, there's not much losses, so they can just keep it going. So, yeah. There was the crop, just about the multi-species mixes. I'm more about the simple mixes, or just a single species that makes the most sense. The research on that is still there's a lot of different perspectives on that out there. But there was a really good scientific study where they took a meta study where they took all the different studies that they could find, and they standardized the data, and they found that I think 80% of the time there was no difference. So you were better off just planting the best species. And then in the time when there was an effect, that actually they found that most of the time it was actually the monoculture did better than the multi-species mix. So, but that's one way of looking at it. So.
I think oh my goodness, Michael Jackson's in my pocket. The discussion kind of came to a point that I expected it to, is that there is a lot of conflicting data. There's a lot of conflicting information, and the way I've always seen cover crops well presented is understanding your goals. And you mentioned nitrogen as one way of looking at it. Really what we want is ground cover too. We want the erosion protection, the soil health benefits. There's a few different ways to angle it. And then depending on the system that you're looking for, if you have a really clearly defined system that you're working towards, then you can kind of take the steps to get there. But half the time we don't know what that magic regenerative farm is. We probably didn't know what the magic zero-till farm was either. But the point is continued learning and local and regional adaptation. I've also experienced what appeared to be the perfect system, and after 10 or 20 years you realize it's not. And then there's another environmental catastrophe. So that's kind of what I saw in New Zealand. Very much a pastoral type environment, and lots of cattle, single day rotations. They're doing everything that we have deemed as the best approach, and now they have nitrate contamination in the water to the point where they have government regulating how much fertilizer you can put down. So I think it's important that we understand the ebbs and flows, that there are perceived benefits to one approach and negative benefits as well, and it's really quite complicated. So you have to look through the sort of the mix, what's right for your environment with your goals in mind, and at the same time, where can we have some wins? So this is where, like, what would make cover crops work in dryland southern Alberta? And then I've heard somebody say it here too. Well, it looks like this kochia is a pretty damn good cover crop. It is, and we have everybody bragging about genomics saving the world, but we have these technologies, but we don't have ways for them to use it in a way that actually matters to farmers. So you have to think about those little things. What would be perfect for me to do this? And then we need to, figure out ways to communicate that to scientists and such, so that they can start working on it. So with that, unless there's any final questions for Scott, I want to join me in thanking him.